What class is this? Good morning, geometry. Today we're going to look at the next section of trigonometry, section 13-2. And section 13-1, we focused on the tangent ratio. Today we're going to look at the sine and the cosine ratios. And our essential question for this section is, how can you use the sine and cosine ratios and their inverses in calculations involving right triangles? Now, once again, trigonometry is the study of triangle measure. So we can take a right triangle, or we can take some other special triangles, or we can take obtuse triangles and apply the ideas of trigonometry. But what we're focusing on in here is right triangles. Tomorrow, or the next section, we'll focus on some of the special triangles that we'll run across. But trigonometry is just, like I said, finding the angles and the lengths of sides of a triangle. Now, before we got to chapter 13, if we wanted to know the length of a side of a triangle, we probably had to use a ruler, or the problem would have given the value to us. Also, if we wanted to find the angle measure, we could have used a compass. Again, those are the beginning stages of how to find the measurements of a side or the measurements of an angle of a triangle. So now trigonometry came along and avoided all that. Now, section 13-2, again, I am not worried about this part. It's just the explore, not important. But what I want to focus on is the top of the page of 698. Finding sine and cosine of an angle. Now again, I've highlighted two thoughts up there. I'll get it orange, that means it can go into your HD and Cs. But in the world of trigonometry, these are classified as functions. We don't get to graph these at all in geometry. You'll probably see that either in Algebra 2 or Pre-Calculus. But there are 6 trig functions, and what we are just focusing on is 3 of them. And all 3 of these have a special meaning. Okay? It all depends on what they give you in the triangle. We've already did tangent, and we already found that tangent of an angle focuses on the opposite side of the angle measure divided by the adjacent side. The other 2 in here are the sine and cosine. Sine involves the opposite side divided by the hypotenuse. Okay? Cosine is the adjacent side divided by the hypotenuse. Now, if you can get this memorized, that is 3 of the major trig functions, SOHCAHTOA, and it's also seen here on your calculator. Sine, cosine, tangent. SOHCAHTOA. And if you can get that memorized, you can find any angle measure, you can find any length of a side of any type of right triangle. All right, so in the problems here, in the examples, they have given to us a right triangle. And I want to focus on letter B. And they want us to find the sine, or write the sine and the cosine of this angle as a fraction, and as a decimal rounded to the nearest tenth. So again, first things first, we want to find sine of f. So we're trying to find this guy right here. And sine function is opposite divided by the hypotenuse. So if you take the angle f, the opposite side is here, which is 15, and the adjacent side, or so the hypotenuse side, once again, the hypotenuse is always the side opposite the right angle. And you'll see that in this case, we try to find the sine, so we do the opposite divided by the hypotenuse. We get 15 divided by 17. So to find that, it's really easy. Again, we know that 15 divided by 17 is 0.882, rounded to nearest tenth. So the sine of this is just 0.882. Now these values have some significance, but right now we're just focusing on how to find the sine and cosine. It really involves the unit circle, which when you get to that either in Algebra 2 or into pre-calculus, it'll make a little bit more sense, okay? Now the cosine of this angle F is the ka. Cosine is the adjacent side divided by the hypotenuse. So we got to look at our diagram. Our adjacent is a length of 8, and our hypotenuse is a length of 17. So 8 divided by 17, we would find that the cosine of angle F is 0.471, rounding it off to the nearest thousandth. Now be very careful when it comes into your directions. They're going to tell you what you're going to round it to the nearest. Again, I have no problem if you round your answers to the nearest hundredth. That'll be fine with me. All right, once again, if you get this part right here down pat, you have accomplished a great understanding of trig. All right, let's go to the next page. The next page is using complementary angles. Okay. Now again, this one's not that difficult, because if you got to go back and ask yourself what is a complementary angle, we know that the sum of the angles of a triangle add up to be 180. Well, we already know that this angle right here is a right angle, so it's 90. We don't need to worry about him. What we need to do is look at this angle measure and this angle measure, and the sum of these two angles have got to add up to be 90, because if you go whatever these are is 90 plus 90 of the right angle, that's 180. So this is not a very difficult section. They give you a special formula, but you just got to remember, again, this is part of the trig. These deal with the complementary angles. All right, now down below is a quick example. I'll let you guys copy that down. I'm not going to get into it because it's not that difficult. You can just pause your video and write that down and come back and check it out. All right, let's go to the next page, page 700. Here is two examples. And the first one, number 8, says, well, we know that the cosine of 73 degrees is approximately 0.292. We want to write the sine of a complementary angle. Well, we already know the cosine is the angle 73, and it's complementary. Again, taking this part right here, solve for theta, we know our complementary is going to be 17. Well, I'm only using the formulas here, but you already know that if I take 73 plus what will give us 90, you'll see that our angle, that other angle is going to be 17. So the sine of 17 degrees, okay, it's very simple. How did they get this answer? You go to your calculator, you find the sine button, and you type in 17, and you hit enter. Same thing with number 9. Now I need to stop for a second and go over something. If your calculator has two different functions in there that you can use. If you did this problem and you got a different answer than what the Bob would say, that tells you that you had your calculator set up wrong. What I want you to do is I want you to look at the top of your screen. Okay, you see that word degree right there? That guy right there is telling us we're dealing with degrees. If you don't have the same answer in the back of the book, that means your degree, you have your calculator set up wrong. So what to do to fix that, what you're going to do is you're going to go to mode. And in your mode, you need to look down here to the third line where it says radian degree. And if the degree is highlighted, that means your calculator is going to be in degrees. But if it's set up in radians, which is something else that we're not going to talk about in geometry, you'll get that in pre-calculus, you got to make sure that this is in degrees. If it's not in degrees, you're going to get a different answer. All right. Now, down below, like I said, if you go and if you understood, have a full 120,000% understanding of this right here, you can do anything in trig. Everything in trig falls upon the 6 trig functions, and all we're focusing on here are 3 of them: sine, cosine, tangent. The other one is cosecant, secant, and cotangent. We won't worry about that in geometry. All right, so let's look at how this is done. Okay, here we have a 12-foot ramp installed alongside some steps to provide a wheelchair access to a library. The ramp makes an angle of 11 degrees with the ground, this being the ground. Our job is to find each dimension. That means we want to find how high up it is and how long it is. Well, let's back it up. What's the length vertically and what's the length horizontally to the nearest tenth of a foot. All right, so the first thing we'll do is look at our problem here. Again, this is our given. Find each, okay, let's see where we're doing here. It doesn't matter which one. Okay, the first part is that they want to find the height of x, okay? So we're given the angle, we're given the hypotenuse, and we want to find the height of x, okay? Angle, hypotenuse, opposite side. Angle, hypotenuse, opposite side. So that tells me I have to use sine. Sine is the opposite divided by hypotenuse. And I'll let you guys work that out. Okay? All right, let's go on to the next page. Let's look at the second part. Find the distance y. Well, again, I took my diagram away. Again, we want to find the length of y. They gave us our angle. They gave us the length of the hypotenuse. So side, hypotenuse, adjacent side. Angle, hypotenuse, adjacent side. So that tells me I have to use the cosine. The cosine is the adjacent side divided by the hypotenuse. You got to use the appropriate trig function based upon what kind of information they give you. So I'll let you guys copy that and focus on it, okay? SOHCAHTOA is so important. All right, now what I like you guys to do is take your turn. I'd like you to work it out, pause the video, work it out, and look at your cover sheet or your solutions manual and look at and see if you got the same answer. So here, let's do number 11. Suppose a new regulation states that the maximum angle of a ramp for wheelchairs is 8 degrees. There's a reason why, but we won't go into details. At least how long must the new ramp be? So again, if you look out here in our diagram, we are trying to figure out the hypotenuse, okay? Hypotenuse. And you got to look at what they give us. They give us the angle. They have given us the opposite side of that angle. And our job is to find the hypotenuse. So you got to ask yourself, of these 3 trig functions, which one you want to use? We have the hypotenuse and we have the opposite. So we have to use the sine. So the sine of 8 degrees equals the opposite side, which is 2.3, divided by our hypotenuse. There's the setup. After this is all algebra. So we cross multiply. So multiply both sides by z, and then divide both sides by the sine of 8 degrees. And they want us to round it to the nearest tenth. So all we need to do in this situation is use our calculator. Turn it on, clear it. So take 2.3, divide it by the sine of 8 degrees, close it up with parentheses, and hit enter, and you'll get 15.526. So they want us to round it to the nearest tenth. So it's going to be 16.5 feet. And that is going to be the answer to that question. Now, once again, when you do a problem like this, you've got to go by what they give you in the right triangle, and you've got to ask yourself, am I going to use the sine function, am I going to use the cosine, or am I going to use a tangent? You've got to go by what they give you. Okay? So, now the next thing we'll do is the top of the page, of page 702, is how to find the angle measure to the nearest degree. So again, it all deals with the SOHCAHTOA. Okay, so write in a value an inverse measure of angle R and a measure of angle P. I'll do the measure of, I'll just do one of these, okay? Let's see, how do they go? I'm just trying to figure out which one I want to use. All right, let's see. Let's just focus here on this part right here. Again, we're dealing with this one. We're dealing with sine, which in this case, the sine of angle R is so opposite over the hypotenuse. Okay. Then to find this measure angle, we take what is called the inverse sine of 7 over 13. So how did they get 33 degrees? It's very simple. Ready? Here's the setup, opposite over the hypotenuse. To find the measure of angle R, we divide both sides by the sine. So this gives us the inverse sine. So how do we get this answer 33 degrees? You look at your calculator, you hit the second button, and then go and look at the second button, activates the blue. So that gives you the inverse sine, 7 divided by 13. You close it up with parentheses and hit enter, and rounding it to the nearest degree. So it is 32.5, so we're rounded up to 33 degrees. So in other words, this angle right here is 33 degrees. Then the next part is, let's try to find the angle of P. Once again, P, you're focusing on P. What they're giving you here is the hypotenuse and the adjacent. Hypotenuse and the adjacent. So that tells me I have to use the cosine. So the cosine is the opposite. So, let's back it up. So ca, adjacent, divided by the hypotenuse. Find the inverse cosine of that. So we do second cosine of 7 divided by 13. Close it up, hit enter, and it's roughly 57 degrees. I think I have reached the limit of how much time I want to spend on this section. Again, try the your turns. Go to your answer sheet, work them out, see if you got the right answer. And once again, everything ties into SOHCAHTOA. You get a grasp of this, you have no problem doing this section, and you'll have no problem with section 13-3. These are important. Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse. Tangent is the opposite side divided by the adjacent side. Thank you guys. Have a good day. Catch you later.